So a couple of things that I want to cover is notation. You need to be comfortable with this notation. So if a question refers to this triangle here, they're going to use the letters at each corner. So this is triangle. You pick where you want to start. Usually start here, X, Y, W. Okay. So this is triangle XYW. So you should be comfortable with that. This angle right here that is happening at this corner, how would we call that if you use the three-letter notation? This is how I will show you how to do it. Okay. You pick this letter, you put that down. Right? Put your finger on it and then pick the one that's over here and put that in front. And the other letter that's to the right here. So that angle right there is called YXW. So you start here, YXW. The letter that's in the middle, that's where both of them meet. Okay? I saw some difficulties on a test with this. So if you wanted to refer to this angle right here, you go angle, W, but then you pick which one. Either one of these has to be on one of the ends here. So if you want to start with this, have that X there, W, Y, that's right here. So the angle notation precedes the three letters, okay? There's a triangle. If it's triangle, it's just talking about this triangle, but this is angle, angle. One more here. If we're talking about this angle right here, you go angle Y, because that's the one that's in the middle, and then the other two letters that form it go on either side. So it doesn't matter if you want to go W and then the X or XW, it doesn't matter. So each angle can be written using the three-letter angle notation. Does that make sense? Let's try one more. We go over here. If I wanted to refer to this angle right here at this corner, right, I go angle E, right? But then you kind of go travel out until you get to a point that's D, then go back to the angle you're interested in, travel out of that one, and I know, I made a mistake. Were you going to say that, Kim J? This is not E, right? This is F. This is E, right? Sorry, my bad. Go ahead, Kim J. For length, okay. I'm gonna get to that, so I will finish this. Okay, you do it. You need to wake up. Well, how would you do this angle right here in this corner? Write it down on your paper. How would you refer to this angle right here in this corner using the three-letter notation? Just go ahead and do it. Same with D. How would you write that angle right here using the three-letter notation? Just give it a try. On page 177. Just make sure you have an eraser, right? If you're scared, don't be scared. You can do this. Ready? Drum roll. Okay, I want that angle. I'm going to put my pencil there, travel out. There's D. Back to where my pencil is, travel out, that's F. Okay, so if you ever need to find it, just focus on the middle, right? Okay, it's right here. And then what are the letters that are to either side of it? There's D there and F there, so we're talking this angle formed right there. And this one here would be D in the middle. Travel out, there's an E there. Travel out, there's an F there. These two do not matter which one you put first. You could have placed F there and E there. Doesn't matter as long as the middle stays where it's supposed to. Okay, the one you're interested in. Okay, does that make sense? Okay. All right, next. If I wanted to refer to side length, if I wanted to talk about side W here, we call it W. There's another way of referring to this side length, and it is called like XY. Right? If you want to talk about this specific stretch, we call that xy. From here to here, just read those two letters. It's, how about we do y? Y. Right? Or u, right? Whatever you want it to do. And then xw, wx, two-letter notation. It's just the stretch between those 2 points. And then here, f to e, right? Or side f. See? So either one will work. FD, and this would be DE. Okay. So I personally, when the question says, hey, find side DE, I go find it and just put an X there or a Y or something. If the question ever gives me a 3-letter notation, I go find it and put a letter in there so that I don't have to deal with a 3-letter notation over and over. It's just easier for me, but you need to know how to find them and where they would be located. Okay. Now, let's do some solving. They asked us to solve, right? It says solve for side W. They want this side here. What law would I use to do that? Why am I saying law? You can't use Pythagorean theorem because you only have one side. But you do have this angle and this angle. You can easily find the third one and then you have a pair. So angle Y is 180 minus 90 minus 41. So that would be 49 degrees. Okay? You know now that this is 49. And so now you have a pair. And you use that pair like this. And you want to find W, right? So it's sine of 90 over W. And then you cross multiply and divide. So W is 4.2 times sine of 90 over sine of 49. Anybody remember what sine of 90 is? It's 1. So it's basically 4.2 divided by sine of 49. I need my calculator. 5.57, right? And we are in meters. Now that you have two sides, you have this side and this side, you can use Pythagorean theorem to solve for this one if you wanted to, because it's a right triangle. Okay, that's that. Let's do this one here. I'm going to ask you to change this. Calculate the measure of DE. DE, where is DE? Is right here. We're going to call that X. Okay. So you should notice it's a right triangle. We've got 2 out of the 3 sides. Okay. Right triangle, check. 2 out of 3, check. Pythagorean theorem. Okay. And we should recognize that DE is what? Hypotenuse or leg? It's my leg, right? So I'll go x squared is equal to 3.9 squared, which is the hypotenuse, minus the other leg. I type that in. 7.37. Square root that, 2.71. Which makes sense. It's not longer than my hypotenuse, which is the longest. And we have ourselves a deal. Question. If I had to classify this, what would I call this particular? What's the first and last name? We know it's right. is a right angle. What do I know about the sides? They're all different, right? So scalene. Isosceles, no. Equilateral, definitely not, right? So it's scalene. So because we found that third side, we could now tell, right? What about this one to the left here? It's a right, yeah. Scalene, yeah. Why scalene? I don't know this one still, but all three angles are different, right? You're guaranteed all three sides are different as well. So no need to figure out the rest. So both of these are right scalene in this case. Okay. So that covers notation, and that covers a little bit of sine law, cosine law. Okay, so I'm going to pause here. All right, so use the following diagram to answer the questions. What's the measure of angle M? So two marks here, and this is why. First of all, you should have recognized that these markings tell us that these two sides are the same, which means it's like a chain reaction, right? So you're like, wait a minute, so if a 13 has a 42 across from it, then this 13 must have the 42 degree across from it. So if you came up with this 42 there, you get a mark. Okay, does that make sense? So equal sides have equal angles across from them. That's just a fact, right? Different sides will have different angles and vice versa. So here's how you find M. Angle M is found by going 180 minus 42 or minus 2 times 42, whatever works for you. And so that's 96 degrees. So now I know that this one up here is 96. So if you get that mark, you obviously get that second, right? The 96 gives you the 2 out of 2, I would say. Okay. Then it says classify triangle MNP. So triangle MNP, which is this one up here, right? By angle measure and side length. Now, because this is greater than 96, you know that it's going to be obtuse. So if the word obtuse shows up, you get 1 mark. And because two sides are the same, or two angles are the same, whichever one you want to pick, this is an isosceles. So obtuse isosceles is, so you get 1 mark for the obtuse, 1 mark for the isosceles. Yeah. A is 2, you get 1 mark for this here, and 1 mark for getting the 96. Not too bad, right? I even guided you through it. I could have just omitted this whole thing and just been like, hey, classify that thing, right? But it actually kind of gets you through the steps required before doing that. So then question 2, classify each by angle and side length. Give reasons for your classification. That, like this, give reasons is basically the work that you might have to do to actually answer it. So if you add this up, that's 90, right? So this must be a 90 here. Right? These two add up to 90 degrees. You take 180 minus 90, you're left with 90. So that is, to me, reasons for classifying. So you say that this is a right, and because all three angles are the same, this is a right scalene. That's it. So I think we're going to change this out of 4.5. We're going to change that. I'm going to make it easier to mark instead of doing half. So you get 1, 1. Right? One right, one scalene. Then this one here, this one is interesting. I may not have specifically talked about this one, but if these two sides are the same, then these two angles across those sides will also be the same. So this is how you do that one. You go 180, right, minus 150, right? You subtract the 150 from 180, and that number will be split in half, right? Because these two, they split that remainder. Does that make sense? You're splitting the what's left over in half. So it's 30 divided by 2, so they're each 15 degrees. Not that it really mattered, like you could have answered without it, but I want you to know how to do that. So this would be an obtuse isosceles. Again. It would be an obtuse isosceles. Next, so you got 1 mark for the obtuse, 1 mark for the isosceles. The 15 didn't have to show up there. You could have just answered without figuring out the 15. I just want you to know that I'm using this as a lesson, right? The third one, watch carefully. When you see two sides being the same, do this for yourself. Just do like mark, like I'm confirming with the markings that they're the same. So that means that if I go across this one, that is the same, and across this side, these are also, like these two angles will be the same. So you apply the same strategy I just showed you up there. Take away the one you know and split the remainder in half, right? So a 180 minus 60 is 120. Split that in half, you get 60. So that means that this is a 60 and this is a 60. And that's when you realize, wait a minute, 60, 60, 60, that's an equilateral. You don't have to write the word acute equilateral, it's just equilateral is fine. So I'll just give you 1 mark for that. So this is now 2, 4, this is out of 5. So yeah. You don't lose marks. No, you do not lose marks for that. It's like saying, it's almost like saying, you know, when it's x, instead of saying x, you say 1x. It's the same thing. Okay. Okay. Where did I leave the extras? Coda, you want one of these? Just to follow. Have your hands full there. Anyways, so 2, 4, 5. So question 2 is out of 5. Let's do that right here. So question 2 is out of 5. So 2, 2, and 1. Actually, sorry, leave it like that, out of 5. I would have probably on a test given you 1 mark for figuring this out, 1 mark for that, but we'll leave it out of 5 today. Then sketch the following triangles. So it's a right scalene, so you have to use markings that make that happen. So right, take care of that. Scalene, this is how I would take care of that. If you went 3, 4, 5 inches, feet, whatever, right? Give each side a different length, that's also valid. So 2 marks for that if both categories are met. Yeah. You all, yeah, that's right. Is there a 90 though in there? Okay, as long as there's a 90 and the other 2 angles are different, sure. And it has to add up to 180. Yeah. Yeah, absolutely. So let's do that. Like if you did this, right? This is a 40 and this is a 50, right? Then it's 90, 40, 50. They're all different. That's also scalene, right? All right. So 2 marks if those both criteria are met. Obtuse isosceles. I didn't leave myself a whole lot of room, but I'm just gonna. You actually had examples of obtuse isosceles on this paper, right? So this would be 110 for me or something, right? You've got to make sure it's bigger than 90. And then just make these 2 markings there, or put like 10 centimeters, 10 centimeters, whatever. Like, or have both angles here being the same. So 110, take over 180 at 70, 35, 35. If I had put down 35 degrees here and 35 degrees there, that would work. But you know, whatever works for you is fine. 2 marks as well. Because you need to, right? It's almost like naming it. You need to make sure both are met, right? And the last one, I just wanted to have a little fun with you. There is no such thing as an obtuse equilateral. Can't be sketched. All angles are equal to 60 degrees, right? It can't be, it has to be a cube, right? So this one is only 1 mark if you explain. If you graphed it, you just get 0 on it because there is no such thing, okay? If you did that paper that I gave you to do the homework, there were a couple of the ones that cannot be sketched on there. So just look that up. Solve for length of the side x there. No angles, thank goodness, right? I have a pair, so sine of 90 over 2.8. Sine of 27 over the side that's across from it. Cross, multiply, and divide. I'm just going to give you the answer, even though you need to show me work, right? That's the answer there. This one, let's get rid of the 4.5 here. We're going to make this worth 2. 1 for the setup and work, 1 for the right answer, so 2. Okay, pair, sine of 49 over 20.2. If there's a pair, it's sine law. That's it. But you need this angle, correct, to find x. So sine of right over x. I don't know how to do that yet. So you can give it a letter if you want, but I'm just going to do this. 180 minus 90, right, minus 49 is 41. So now I know that that's the angle that comes in here. So you get 1 mark for the 41 if it shows up there. Then you get 1 mark for setup and work, right? So you do cross, multiply, and divide. So that gives you 17.56 millimeters. So 1 mark for the 41, 1 mark for setup and work, and 1 mark for the correct final answer. So question B is out of 3. I'll get it in a bit. Yeah. Question? No? So this one is out of 3. The first one is out of 2. Okay. The next, Pythagorean theorem. Even though you do have a pair, this side would allow you to find that angle. That's a lot of work, right? In my books, you can still do it. You're not going to lose marks, but I'm going to use Pythagorean theorem. This is my hypotenuse, meaning I'm missing a leg. So x squared is going to be hypotenuse squared minus the other leg squared. Square root that. You type that in, you get 1883, 84. This is 43.4. 40 feet in my. So this would be worth 2 marks if you do the right setup and the correct work. 2 marks there. The bonus I will just show you on my key. So yeah, go ahead. So this is the bonus. You can cut this here and you split that 50 in half. I'm going to talk about this though. This is a dangerous move. Some students think they can always just split that in half, right? Not always. It's only with an isosceles or equilateral. You cannot do that with any other triangle, okay? But we know it's an isosceles, so when we cut it, it's 50 split into half, 25. This, I use Pythagorean theorem to figure out that height. I would give you 1 bonus mark if you found the height of the triangle. And then another mark for figuring out the area, which is base times height divided by 2. Yeah. Here, 42. A bit different. That's fine. I'll give you the marks. So 2 bonus marks if you got that, if you got this right. If you're a little bit off, that's fine because you rounded here. That's fine. So what is it out of now? I have to redo this. 2, 3, and 2. So the back side is out of 7. I'm not counting the bonus, right? not counting. So 7. Then the first question was 2 and 2, so that's 4. Then this is out of 5. That's 9 already. And this was out of 5 as well. That's 14. So the front is out of 14. The back is out of 7. That makes us out of 21. So scratch the out of 15, make it out of 21, add up your total, flip it upside down, pass it forward, go back to the book. 2 marks. Yeah, the bonus is 2 marks. Oh yeah, that's my ideal. You'll never lose marks for that. Okay, page 182. So I got this. Okay. All right. So I'm gonna we're gonna wrap up triangles today, okay? I don't know how you wrap up a triangle, but anyway, we wrap up triangles today. Then we're gonna go quadrilaterals tomorrow. What's that? And then what is tomorrow? Thursday, which is basically Friday for you. So then next week we do polygons, pentagons, hexagons, octagons. Yeah. Yes. Yes. You're gonna get them back, but I'm gonna take them back after you see them. So I will get you started here, and then maybe it's still recording. It's okay. Then the next thing is quadrilateral tomorrow. A little bit more quads when we come back, then polygons. And I think we're on track. We're going to be on track to writing our test the Friday before spring break, which is the 25th. So unless you want to come in on Saturday. Want to come in on Saturday anyway? Yeah. I used to do that actually, believe it or not. Like way back when, there were some students like, yeah, let's do it. So they got an extra day to study, right? And I couldn't believe it. They volunteered. Anyway. So yeah, a little dry. I know it's not like the math you're used to. Like you just want to plug into the formula and solve for that final thing. But you know, there's going to be some of that coming up. So have your study sheet ready. Get a piece of loose leaf. Add some stuff. You have that available. You just need to do some work for it, right? All right. 182. Let's go. So these are. You're going to recognize some of these from the AC. So let's go ahead here. I'm going to be a little quicker because some of them we know. But you don't have the AC anymore, right? So this is going to be for your notes. So because these are the same, right? I know that this one is 60 as well. Which means that angle M is going to be 180 minus 60, which is 60 degrees, right? So if you classify M and P, right, it's an acute equilateral. I will put this under optional, okay? It's optional. And then let's continue here. Use the following diagram to answer the questions below. And watch the notation, okay? What is the length of PR? PR is right here. This is what they want, right? That's we can call this X, right? We can call it right next to PR, right down side X like that. And we know because of the markings that this is 8. And if you look carefully, what kind of triangle are we talking about? The box here tells you it's a right triangle, right? So X is the hypotenuse, correct? So many labels, PR, X, hypotenuse, yada, yada, right? Just be comfortable with it, right? It's like you're having a first name, second name, and a nickname, right? Like we're all referring to you, right? So we can go X squared is equal to 8 squared plus 8 squared. We add the legs, right? So 64 and 64 is 128. Take the root of that, that's 11.31 meters. So you found that. Let's continue. Classify, there's a bunch of triangles here, so be careful. Classify triangle PQR. PQR, they want this triangle to be classified. I know it's right. Because of this box in the corner, it's a right triangle. And what is it in terms of its sides? It's definitely an isosceles. Page 182. It's definitely isosceles because these two sides are the same. Okay, classify QRS. QRS, where is it? Triangle QRS. It's right here. QRS. So I'm going to highlight that because it's hard to see. So QRS, I'm going to highlight it like that. What kind of a triangle is that? What do you yeah, if this is a 90 here, you're guaranteed that it's a 90 on the other side. It's a straight line, right? It would add up to 180 along that straight line here. So this is a 90. So we know it's a right. And what would you say in terms of its side length this would be? It could be a scalene or it could be an isosceles. We don't know for sure. But if you focus here on this one, we split this in half. This used to be 1131 from end to end. So I'm going to do this. Draw it like this. This is there. This is 11.32 divided 11.31 divided by 2. That's 5.66. Without doing a lot of math, we figured out that I can split this in half. If you have an isosceles triangle and you split that in half, this you can just take that side length, divide it by 2 and get that. I know that this here down here is 8, this, right? And this is still unknown to me. Okay, we can call this y. I have a pretty good feeling it might be isosceles. We don't know for sure. Let's try it out. So this is a leg, right? So y squared is equal to, sorry, not square root yet. Hold your horses, right? 8 squared minus 5.66 squared. Y is equal to square root of, let's figure that out, 64 minus 5.66 squared. That's 31.9644. Write this down. 5.6 45. And this is where we run into a bit of trouble in this unit. I'm not going to do this to you like we are meters, right? Would you say that they're basically the same? In this unit, you can do that. It's going to always be an issue, even though if you used all the decimals, I can guarantee you it'd be exactly the same. So we would just say write isosceles here. Yeah. So if it's that close, you have my blessing to just say they're the same. Okay. If it's that close, yeah. Yes. So what? That's a good one. So pay attention. Put on your thinking caps. At the very beginning, if this is 8 and this is 8, then what do we know about the angles that are across from them? They're the same. So if this is 90 and you split the remaining 90 in half, what must these two be? 45, right? So if this is 90 and that's 45, what must this one be here? It must be 45 also. So with this, you could have already concluded, right? If this is 45 and this is 45, you could have come up with the same conclusion. Yeah, good catch. So this is on the difficult side. This is on the like what's going on here. Just start solving for things, and you might come up with something, right? That's my suggestion to you. Okay. What I'm going to ask you to do is to work on this. Work on 183 and 184, and I will hand out your tests in the meantime. It sounds like a lot, but it's just 2 pages with 1 question on each page. Okay.